Hi, my name is Steve Rahi. I am a premier field engineer specializing in management technologies. Today is part 23 of a series focusing on operating system deployment, initially in ConfigMgr 2012, now continuing into ConfigMgr current. The topic for this session focused specifically on a new piece that was introduced as of ConfigMgr 1710 called nested task sequences. So here's our agenda, basically going through what are nested task sequences, why we care about them, what the requirements are, really kind of detailing a little bit high level how they work, kind of give you an idea about task sequencing reimagined with this nested task sequencing approach, let you see a few scenarios in action, then talk about finally troubleshooting, and we'll be done. So what are nested task sequences? Well, nested task sequences, probably a few more bullet points that I could put than I have here, but essentially nested task sequences are task sequences that have a parent-child relationship, right? Where you can take a parent task sequence and branch off and call, if you will, child task sequences. One of the things about these parent-child task sequence relationships is that all of the steps from the various joined task sequences are brought together and effectively combined and sent down as a single policy to the client. So said a different way, this idea of nested task sequences primarily doesn't really change anything that happens on the client. So whether you have a 400-step individual one single task sequence, or you have 40 individual task sequences all joined together to do the same thing at the client, it's going to be one big policy. Doesn't really matter whether it's nested or not, right? Now, one of the other things, and largely this shouldn't apply today, really did apply more in the Configuration Manager 2007 world with complex task sequences, but there was a size limitation. So nesting the task sequence, since it is applied as one big policy, the same size limits, if there are any, haven't heard of any of Config Manager 2012 forward, and haven't had any customers run into that, if they even still exist. All of that still applies, right? When it comes to the client, again, it executes the same way as it always has. A few minor changes, but that's it. The nested task sequence, basically, it's still a global task sequencing environment. The variables that are declared in one part of the task sequence environment, whether it be the parent or the child task sequences, all kind of share that global environment. What this really does is it helps bring organization to your task sequencing. So rationalize the relationships between different branches of your task sequence. The execution proceeds normally. It is linear. It writes to a single SMSTS log, right? The parent task sequence does not spawn a child task sequence and then continue processing. It will wait for that child task sequence to be done. You'll see that in a demo here in a bit, right? So again, we organize the task sequence nesting is really on the server side for the administrators, for those that are building this, a good way to bring rationalization and so on to the way task sequences are engineered. So then why do we need them? Well, again, obscure, organized task sequence complexity. We have some environments that have very significantly complex task sequences. The parent-child relationship is going to help you rationalize, segment that complexity, helps you understand what exactly is happening and when. So kind of tapping into the next piece, modularized task sequences. You know, when we think about code, we think a lot about reusing code. I write a lot of scripts. I will routinely reuse certain scripts that I have written, sections of scripts that I've written, and plug them into other ones and keep going. If we think about task sequencing that way, this nested approach enables us to be able to modularize our task sequences. If there's a particular section of a task sequence that generally applies to every task sequence we build, then build it as a nested task sequence and just pull it in. So we have that section modularized and maintained separately, right? The idea of distributing software. There may be some software that's universally distributed as part of a task sequence, where that other sections of software are unique to certain business units. Well, you can handle that too in kind of a modularized approach. Easing the task sequence design, right? Again, modular, so that if you do have a change in task sequencing, then it's pretty easy to maintain that change in just the single modular task sequence that that has changed, right? Instead of having to go into now multiple task sequences and change them there. Let me say that a different way, because I think that's an important concept, right? So through the years of working with task sequencing, have been asked a few times about how do I engineer my task sequencing in such a way so that I don't have to go touch every single task sequence I maintain if a single change is required. Well, great question. Nested task sequences are the answer to that, right? Because if you modularize things and you're reusing those modules with other parent task sequences, then if you need to make a change in one of the modules, you do it one time, and it applies to all of the parent task sequences that leverage that module, right? Testing, huge. How many times have we, in fact, I've read blog articles on it recently, where someone was complaining that, why is it that every time there's a problem with the task sequence that's being re-engineered and tested, it waits until the very end of the task sequence to manifest, and then to try to track that down and troubleshoot it requires rerunning the entire task sequence to get to that point and troubleshoot. Well, if we can use nested task sequences now, that's largely a thing of the past. If we make a change in the module of the task sequence module that we need to update and run that and verify that it runs successfully, then plug it into the parent task sequence, it really shouldn't be any different at all, right? Okay. And then lastly, nested task sequencing. This approach will support whether you're imaging or whether you're doing a non-imaging task sequence. One thing I'll point out, again, I'm sure later, in fact, I think I pointed out on the next slide. Yeah. So starting with the second bullet point, boot images, let's say it this way, task sequences that have a boot image associated are not eligible to be used as child task sequences, right? You might think that you need a boot image applied to any task sequence. That's not true. Only the ones where you're doing imaging and you need to be able to boot and associate that task sequence, right? And know what media you've booted with and so on. But for the nested task sequences, the child task sequences, there's no expectation that you're going to boot and begin imaging directly with those, because it's just a part of the overall task sequence you want to deploy, right? The other inference here is that child task sequences themselves do not need to be deployed in order to work with the parent task sequence. Remember, at the server, whenever you deploy a parent task sequence, it knows what child task sequences it needs and will compartmentalize all of that up into a single policy body and send that down to the client, right? Now, bullet number one. So when did all of this become available in Config Manager? Well, it first released as a part of Configuration Manager Current Branch 1710. I believe that was actually a pre-release feature at the time. Now, in 1802, it is no longer pre-release. You can enable it, use it however you like. Another question that sometimes comes up is the client important? The version of the client important for this? Well, if you're running a task sequence through the client, yeah, you need to have your client updated to 1710 or better, enabled for the client to understand what's going on. If you're just doing an imaging task sequence, then all of that's going to come from the site server anyway, and so it should be fine. In terms of how this works, a bit of a diagram here just to kind of show you the flow. And basically, this whole section to the left is one single parent task sequence. And so this is illustrating the handoff. So basically, we run through the first few parts of the parent task sequence and get to a point that we're going to call our first child task sequence. So then we're going to get into the child task sequence and process through. And then somewhere along the way, we're going to call a third level task sequence. And so let me pause there. I've tested, you'll see in a minute, the a 3-level depth in nesting. I haven't ever heard that there's a set limit in terms of the number of nested task sequences you can have. There's certainly a practical limit because it gets confusing at some point. I would even think maybe 3 is a good practical limit, but no hard limit I've found, right? So once we get to this child of a child, 3 levels deep nested, we'll process through. This one completes. We hand control back to this one. Processing finishes. Now we hand control back to the parent task sequence. Remember, this is one big task sequence. So now we're in this part and we're executing along. Finally, we get to another place that we're going to call a child task sequence, run through those instructions, hand back to our parent task sequence, and down we go, and we're done, right? Processing at that stage is complete. Again, one global environment whenever I'm task sequencing. I could draw a circle around all of this because it is treated as one unit whenever the client receives it. So the best way to kind of nudge into this is to see how this works. So the first thing I want to do is kind of start with an example of how you might think of breaking down your more complex task sequences. And the one that I'm going to show you is really probably the best example I have in my lab. In your own environment, you might have more complex task sequences, but the theory kind of is the same. So let me pull in my lab. All right, so basically what I have is my task sequence folder here. I've got a couple of child folders to drive separation of the demo. So the first one, kind of reimagining what it might look like to break up a complex task sequence, make it more bite-sized and usable. I think of the kind of task sequence that's produced by the MDT wizard. And love MDT, right? It does a great job of doing what it needs to do, trying to cover all the bases for imaging scenarios. But when we look at the task sequence that is created by the MDT task sequence wizard, it is pretty complex, right? In fact, one of the things that I will do if I go into an environment where the customer who's using the MDT integration wizard, one of the first things I will ask them to do is look at this task sequence and walk me through exactly what it's doing. And the reason I do that is to illustrate the point that a lot of times people don't have any clue what their task sequences are doing. And that's kind of a challenge whenever you're relying on this to provide imaging for an enterprise deployment. You kind of want to know what it's doing. You kind of want to understand the flow of it, because if you need to modify it somewhere, you need to make the modification in the right place and so on, right? So I'll show the task sequence and scroll up and down and show them the complexity, ask them to tell me what's going on. Some may have a general ability to say, well, this is happening in this section, and they may be right, but there's a lot of complexity even under the covers here in terms of the way things hand off back and forth, right? So I just use this as a way to illustrate. You see all these different sections. There's initialization and validation and state capture, pre-install, then there's the install and post-install, and on we go as we scroll up and down. So what if we were to, instead of having this in one big monolithic linear task sequence, what if we were to modularize, right? It might look something like this. So here are my modular, my redesigned modular approach. So here I have my, and I haven't tested this, so I'm doing this more for illustration purposes than actually running through the imaging scenario, but hopefully you get the idea. Here I have the parent task sequence. And now all that I'm doing in the parent task sequence is handing off to other child task sequences. You see, if you really look at this, the only thing that really visually has been added is this option to run a task sequence. That's what I'm using, right? So I just specify out, I will browse and be asked what task sequences I want to pull in. These are options. Since none of these have boot images on them, I can pull in any one of these that I would like. So I've just taken those various phases and broken that down into this parent task sequence. So whenever it comes time to run, this parent task sequence runs, calls what it needs. But as I need to edit things, I can make changes to the specific module, task sequence module, that I want. So if I'm in the initialization stage, great, I'll just go edit that one, and I can go see just that section, right? And then if I want to look at the pre-install, I can go look and edit just that section, right? A lot more friendly on the eye to try to sort out what's going on than to try to deal with that big, long structure that is the full task sequence. And hopefully you get the idea, right, of how you could do that to make things easier, to bring a bit more logic, to modularize, and so on. All right. So what about seeing this thing run? So I've actually got 3 demos I want to do. The first one is just to kind of illustrate the flow of the task sequence. So let me go ahead and bring this back in and go into my nested demo. So all of these demo 1s are working together. I'll show you that as a unit. Actually, demo 1 will also be demo 3. I'll explain that as we go along. But I have my demo 1 parent task sequence. And what I'm doing here, let me edit it. All I'm doing is I'm going to set a task sequence variable called demo variable. We'll be able to see this through the process of running the task sequence and see how it runs, what goes on with it, and so on, how it stays maintained if it does through the process of running the task sequence, and so on, right? So I'm setting that, and you'll see that a couple more times, as we go through. And I'm giving it a name that is unique to letting you know this came from the main, the parent task sequence, and it has a value, means it's the first time it was set. Once I set it, I'm going to dump the task sequence variables to a text file. I'm naming the text file chronologically. So this is variable dump 1. And then I'm going to call out to my nested task sequence, which is child 1. So let me minimize this. Then I'm going to go to the child 1 task sequence, edit it, and you'll see that I have the dump variable that I set in my parent. I'm also setting it here, but I'm changing the value of it. So we'll see what that looks like. And then I'm specifically setting a variable that I have not set yet in this child task sequence. And then I'm dumping the variables again, and then the task sequence is finished. I hand back off to my parent, right? And so now, once I get back into my parent, I immediately dump the variables again, give it a name that this is variable dump 2, and then go and again set the demo variables back to a value unique for the parent task sequence, value 2 at the end, dump the variables again. This is dump 3 of the variables. Then I'm going to call a second nested task sequence, child 2, which is right here. All right, and you'll see that I'm going to, again, set my demo variable with something specific here, set a second variable, child 2, to know that I'm setting one inside here, dump my variables again, and then, but this time, I'm going to call a third level nested task sequence, which is over here. And all I'm doing here is I'm going to set my task sequence variable, something specific to this third level, so we'll see how it works out. We'll dump the variables here, and then notice I have a restart computer. So that will be my third demo. Whenever I'm done with this one, I'm going to come in here and enable restart computer so we can kind of see how this runs in a scenario where there's a restart, right? So once I'm done with this task sequence, I'll hand back to my child 2 up here, which then hands back to the parent, which is here, and then I do a final variable dump, and I'm done. So I can kind of track how things have gone along. So this is my parent task sequence. You see that I do indeed have a deployment, but I do not have a deployment of the other 3 because it's not necessary, right? So let's actually go see this run live. All right, so let me pull in. I have a Windows 10 machine here. And let me pull in and run that. All right, good enough. Oops, helps if I type right. And I'm also going to examine my root of my C drive to make sure none of my flag files that I'm creating are there. They are not. So we'll be able to see them get created. So here's my demo 1. I'm going to reinstall it. It'll move really, really quickly here, but you'll see it calling out to the nested task sequences and so on. Hopefully the restart is been set to disabled on this. I believe it has been. Looks like it has been. That's good. And so as quickly as that, we are done, right? But now we have all of these variables that were created kind of in order. So let's walk through. So here's the very first dump from our parent task sequence. And we see, in fact, the setting of this demo variable is set accordingly, right? And then we hand it off to our child task sequence where we redefined the demo variable, the contents of the demo variable, and also added one. We see both here. So demo variable has become set to a different value. I have set my child, I've set a variable in my child task sequence and named it accordingly, right? Then I hand back to my main task sequence and immediately dump those variables, and we see, again, nothing's changed. Everything is the same from the last time. So basically, we're just handing back to the parent. Everything is passed back and forth. Again, a global environment, so everything passes through and is visible. Then I set my demo variable from what it was at the child site, or at the child task sequence, to back to being one generated from my main parent task sequence. So here they are again, right? And then finally, I hand off to my child task sequence. And in this case, I believe I'm going to get also the dump from my third level task sequence. Yeah, here they are. So I didn't dump everything along the way. I probably missed running the script once. But you see, now I have the demo variable with the last setting from the child task sequence. I have a specific variable that was set by the first child task sequence, a specific variable set by the second child task sequence, and a specific variable set by the third level child task sequence. And there they are. And so once that's all done, then I hand control back up to my parent and dump the variables again. And there we are, right? So everything's sustained. So we can kind of see how things flow through the process. Now, let's count this up. We have 6 specific variables that will, or files that are created. So 6, count them up, and I'm just about to delete them. Why am I about to delete them? Because I'm going to run this again, but this time I'm going to modify my child task sequence and enable that reboot step. So let me restart that or re-enable that. Off we go. Then I will do a policy poll on the client in just a minute. So that's demo 1. Demo 2, which I think we probably already know the answer to this, and I've told you already in the start of the presentation, but we'll talk through it anyway, is the question that this answers really is, okay, do these task sequences process in parallel? Meaning, can I have a parent task sequence that's running, call out to a child task sequence, have both task sequences running in parallel and both continuing in their execution? And so I wanted to test that. So what I have is a parent task sequence, and really all it does is it will create, or it will call a nested child task sequence. And then at the end, it creates a flag file to say it's done, right? So we know that this one is finished. So the child task sequence in this case is one that simply, all it does is it sleeps for 10 seconds. So the idea is, if we call the child task sequence and begin the sleep, and then the parent task sequence is able to move on, then we should see the parent task sequence complete before that 10 seconds is up, because all it's going to do is create the flag file, right? So let me go ahead and run this. And so you see we don't have any file called flag file here. So in fact, I will just move that down a little bit, move this up a little bit, and go back to my applications and run my nested demo. And so we'll reinstall it here. We'll see it kick off. We'll see it immediately start to pause for 10 seconds. It's paused. You see my task sequence folder, but I do not have this flag file created. So we know that that parent task sequence has not proceeded, because otherwise it would have written that flag file. We'll see that happen now. It's already written. That flag file is here. So as soon as the timer, the 10 seconds was done, then the flag file was created and we know that we're finished, right? Okay, so let me go in to my control panel and force policy. So ConfigMgr, actions, run a machine policy. So this, I want to get the restart portion of that task sequence where it will actually work this time. So I'm going to get rid of my flag file, and I'm going to run my task sequence now. That should be updated, fingers crossed, and see what it does in a reboot situation. So we're going to run it again, go back here, watch it come up, and this time we'll get five files created prior to the reboot. Here they come. Right, there they are, 5. Now we're going to restart. So count them, 1, 2, 3, 4, 5. And we've saved our environment state. So I'm going to restart now. Let it do its thing. So it'll take just a few seconds while we are restarting to let this thing come up. And then I can log back in and see what happened, right? So we're left with 5. We know there should be 6. So a question that I had when I first started doing this is, okay, will the task sequence progress bars and so on come back up even before I log in? And to be fair, I don't know completely, because this is such a short task sequence to resume that I don't know. But I'm logging in. It could be up so fast that in this case, I'll tell you the answer. It's not going to show up for me. I would see it up here if it would. Of course, as soon as I say that, I'm actually on a virtual machine connection, and so it might have actually flashed and I didn't see it. Nevertheless, what's going to happen is this task sequence does finish up. It's finished up well before I can actually get in to the desktop to actually see it pop up and finish. But it has finished, as we will see. We left with 5 variables, and now we're going to get in, or 5 flag files created. Now we're going to get in and see that we have 6. As soon as I can open up the File Explorer so that I can see it. So one moment while we continue to get our desktop ready. All right, there it comes finally. So let's go to the C drive. And look, and sure enough, now I have 6. These 2, these 4. So the task sequence for sure finished. Another thing I can do is go to the log, which is where I'm going to go now, because the next thing I was going to talk to you about is troubleshooting in a nested task sequence world. And the answer to that is really troubleshooting is no different at all. We still have the SMSTS log. There is a difference for sure in the SMSTS log in terms of calling the nested task sequences, but that's really it. So if I search for start executing and search up, what we'll see, the first one is dump variables. So let's keep going up, and there we go. Run task sequence. Restart computer, right? So we restarted the computer, and you've already seen, so I was searching up, that 2 commands executed after this. The only way that could happen is if after the restart we went back to our parent and finished up, right? Which we clearly did because we see, right? Successfully completed the action, restart computer, and then off we go. Let's see. Updated security. Let's task sequence successfully creating blah, blah, blah. Here, I will save myself some time. There. So starting executing instruction to call nested task sequence 2. And so now we're calling it and off we go. So we see all that, happening in the logs, no problem. So just look for those additional steps as you're going through. But in terms of troubleshooting this, it is not different with any great degree of difference. It's just now looking for the nested task sequence steps and knowing where to go and so on. One thing, so that's really it. One thing in closing that whenever I was sharing this with a particular group, they called out as nice to have, with a linear all-in-one task sequence, you have groups. And you can specify groups that are nested under other groups, and you can specify order of operations and so on. You can do that today as well with any task sequence you build. But what they asked about and specifically thought would be useful, and what we don't have, maybe in the future, who knows, is whenever we ask for a nested task sequence, there's nothing here. So for example, this one calls this task sequence calls one at a level deeper. There's nothing here to show you that by spawning off to this, you're actually going to call a third one too. That would be kind of cool to have, so in your parent task sequence you can see every single thing. Again, not there today, but still very easy to follow just by having things organized appropriately here. So that really rounds out what I wanted to share with you today. Nested task sequences, definitely cool, bring some really awesome ways to help organize things in your environment. So take a look, and we'll see you next time.